Hello, welcome to the FRQ of today. So today we're going to look at the 2007 number 5. I think this one is very much typical of what they're saying is going to be in the exam this year. So let's see if you can figure this one out. So this one says, researchers want to determine whether drivers are significantly more distracted while driving when using a cell phone than when talking to a passenger in the car. In a study of 48 people, 24 people were randomly assigned to drive in a driving simulator while using a cell phone. The remaining 24 were assigned to drive in a driving simulator while talking to a person in the simulator. Part of the driving simulation for both groups involved asking drivers to exit the freeway at a particular exit. In the study, 7 of the 24 cell phone users missed the exit, while 2 of the 24 talking to a passenger missed the exit. Part A, would this study be classified as an experiment or an observational study? Provide an explanation to support your answer. Part B, state the null and alternative hypotheses of interest to the researchers. Part C, one test of significance that you might consider using to answer the researcher's question is a two-sample z-test. State the conditions required for this test to be appropriate, and then comment on whether each condition is met. And then part D, using an advanced statistical method for small samples to test the hypotheses in part B, the researchers report a p-value of 0.0683. Interpret in everyday language what this p-value measures in the context of this study and state what conclusion should be made based on this p-value. So if you want to pause the video and give this one a shot, that'd be great. Okay, now, yeah, this one I think is really typical of what you're going to see this year. It involves no calculator work, okay? And you don't have to draw a chart or a graph. You're just asked about the other parts of it. They tell you the p-value. But the first problem is a very popular problem in the world of AP Stats. Is this an experiment or an observational study? An experiment is when a treatment is being imposed. An observational study is just when they're being observed. They aren't being manipulated in any way. And in this case, a treatment is being imposed, so it is an experiment. And by the way, and so the conclusion we could draw, because it is an experiment, is we'll be able to imply a causal relationship, that one variable is causing another one because it's an experiment. But the way you would word this in part A, you would just simply say this is an experiment because the treatment was being applied, and then you have to mention the context. That's the other thing. Make sure and mention the context. The people were randomly assigned to either use a cell phone during the simulation or talk with a passenger during the simulation. So that's what an experiment is. A treatment was being applied, and then to state how the treatment was being applied in context. All right, so and then state the null and alternative hypotheses for our test. And in this case, we're given proportions. We're given 7 out of 24 and then 2 out of 24. So the big question here is, are those two statistically significantly different? In other words, does it, we had 7 of the 24 that were distracted with a cell phone, only 2 of 24 that were distracted when they were talking to somebody. So which one is, which is that significantly more than that? And that's the question, and it is a proportion. So the null hypothesis is going to be that the two proportions are the same, and the alternative, and what is implied in the problem, is that the proportion of cell phone users that are distracted is greater than the proportion of people that were talking to a passenger. And you have to define your variables. P sub C is the proportion of people like these. Okay, that's who we can talk about here. They were not randomly selected. Okay, so we have to say people like these who would miss the exit in the simulation when using a cell phone. And P sub P is the proportion of people like these who would miss the exit in the simulation when talking to a passenger. Okay, and I went with greater than. It said up here that we were, when driving, it said in the first line, says whether drivers are significantly more distracted while driving using a cell phone than when talking to a passenger. So that would be the clue for the alternative being greater than. So that's why we went greater than there. And then part C asks us to check the conditions. Now that is sinning, okay? That is sinning, but we did not have to check the independence because we didn't have random selection. We had random assignment. We weren't, randomly selecting without replacement from a larger population here. So we had to say randomness, All right, the 48 people were randomly assigned, so random conditions met. Now, it would be independent random if you had two different samples, okay? And so, in this case, we weren't selecting, but I typically told y'all, go ahead and say independent random here whenever you're doing a, like a two proportion z-test, which is in essence what happening here. And I probably should do that to be consistent here. But when you have randomly assigned, you can just say random conditions met. So that's that condition. As the other and we don't have to do independence because, like I said, we don't have sampling without replacement from a larger population. In other words, our population size being at least 10 times our sample size. You don't have to worry about that in this case. But the normalities, n times p and n times 1 minus p are greater than or equal to 10. And that's for both samples in essence. Okay, both for the cell phone people and for the people talking to the passenger. And so I use the pooled p-hat here, which technically is what you're supposed to do. But you could have just used your numbers, n times p and n times 1 minus p. You could have just used 7 and then 17 and then 2 and 22. You could have used those, but the key thing is normality is not met because one of those numbers is less than 10, okay? And actually two of them are. And anyway, so normality is not met in this case. And so that is, in essence, your conditions in this one. And then part D says using an advanced statistical technique, they get a p-value of 0.0683. And it asks us to interpret the p-value and then draw a conclusion from the p-value, which are two different things. Interpret the p-value means say what it means as a probability. That's what the P stands for, is probability. Say what it means in regards to a conditional probability. And what it means is the p-value is the probability of getting sample values this unusual, assuming the null is true. In other words, the p-value means there's a probability of 0.0683 that we would get sample values these unusual, assuming the null is true. But you can't just say it like that. You got to say it in context. And so that is what I have done. So that is what I have done right here. Right here. This p-value is the probability of getting study results where the p-hat sub z is that, and is that much bigger or larger, because that's what the alternative said, all right, then that, assuming the null is true, that p sub c is equal to p sub p. Okay? And so that is describing the p-value as a conditional probability. Then drawing the conclusion from the p-value is this, is to make a decision to reject or fail to reject the null, and then do you have convincing evidence for the alternative. And so this p-value, here's our conclusion, this p-value is greater than 0.05, so we do not reject the null. There is not convincing evidence. That, and then you restate the alternative. That the proportion of people like these who would miss the exit in the simulation using a cell phone is greater than the similar proportion for those talking with a passenger. That is that. And so if you got any questions about that, I'd love it if you sent them to me. And anyway, and or just any questions about the test in general, you having any issues, and so just please let me know. And that's it. I hope y'all have a great day.